Wherever you are, you can join us as we lift up our voice and bless the King of Glory. Maybe I will be a true suffers and a kind of your boy. Sense of Fatase or Gia, be anyone in the same.
Hello, yes, welcome back to yet another video on vectors. In the previous video we look at what vectors are, how they are represented, finding the magnitude or the length and the rest. This particular video we are going to first of all look at the triangular law of vectors very quickly. Then we proceed to finding parallel and perpendicular vectors. Okay. Then we look at the certain relations when it comes to equality, finding missing coordinates in vectors and all that. Okay, so let's see what this video has for us. Okay, good. Now, if you are taking a journey, okay, and then I decide that, okay, let's say we are traveling from Accra we are moving from Eastern region, say Somanya to Kumasi, right? You are moving from Somanya to Kumasi. Then somebody said, okay, first I'll pick a car from Somanya to Accra, right? I'll pick a car from Somanya to Accra. Then I'm going to pick a car from Accra to Kumasi. That's what one person wants to do. I'll pick a car from Somanya to Accra, then from Accra to Kumasi. That's one person journey. So Somanya to Accra, Accra to Kumasi. Then the other person says that, oh, why do I need to pass through this whole stretch? Whilst I can just stand at Somanya and get straight Kumasi car. Okay? So one person decided that, okay, I want to stand at Somanya and pick straight Kumasi car. Maybe that one will not get VIP. This guy wants VIP, but this one doesn't want VIP. So in other words, one takes a journey they are all trying to leave this source or origin to this destination. Both journeys are achieving the same aim. Okay? Both journeys are achieving the same aim. And this is what we call the triangular law of vectors. Okay, what do I mean by this? Now, the guy that is taking the first journey, so he's moving from Somanya to Accra. So, Somanya to Accra. That's the first journey he moved. When he got there, he didn't rest there. He went on from where? Accra to Kumasi. Okay, so he went on from Accra to where? Kumasi. Right. This journey he took, at the end of the day, starting from Somanya, ending in Kumasi. But this guy, we said that it's the same as the journey of traveling straight from where? Somanya to Kumasi. So this is the triangular law of vectors. So S to this plus that should be equal to that. So imagine I'm giving you the vector SA. So I'm giving you the vector SA to be 3, 2. And then I'm giving you vector AK to be say 1 and then 5. And I'm asking you to find vector SK. This should be very simple for you to do if you know the triangular law of vectors. You always know that, okay, if S is starting this and K is ending this, and S is starting and K, then it means that this journey is just like what you are seeing. So then SK will just be the summation of what? This vector plus what? This other vector. Or for instance, I have a different movement like this. A, B, and then what? C. Then A needs to move from A to C. So I move from A to B, B to C, and then someone moves from what? A to C. Then we say, okay, then the movement from A to C is the same as moving from A to B, and then moving from what? B to C. So, same way, if I want to look at the movement from C to A, then it's supposed to be the reverse of what? This. So if I'm looking at movement from C to A, then it's supposed to be rather moving from C to B, then B to A. C to B, and then what? B to A. So that you can see that C is starting, A is ending. Okay, very well. So either of this is right. Now supposing in the question you were not given A to B as a vector and then B to C as a vector, but they're asking you to find A to C. For instance, this is what I mean. What if this one they gave me BA as 2, 3, and then they gave me BC as what? 1, 5. And they're asking me to find A to C. Okay, they're asking me to find A to C. So virtually, what they try to give me is this. What they are trying to give me in that particular question is like this. They're giving me what? The vector B to A. So A, B, C. So they're giving me vector what? B to A instead. So B to A. Very well. B to A. And then they've given me B to C. And then they gave me this one. And they're asking me to find what? A to C. So we are finding A to C. You now, if you look at this journey, you will know that something is wrong with this journey. This is not the type of journey we explained earlier. Okay, this is not the type we explained. We said the journey is always, we are starting from A and then coming to a specific what? Destination. Okay, so it means that moving from here to here should be the same as moving from here to this place to this place. But what we are rather having is moving from here, moving from here. That means that this guy is in the right direction, but this particular vector is in the opposite what? Direction. Are you okay? So in order for us to use the triangular law of what? Vector, then we must change the direction of what? This particular vector, what? BA to AB. And that one we did it in the previous video. If you are given vector BA and then you want to change it to AB, right? You want to change it to what? AB. So we are trying to convert this into this. Then we say, okay, then vector AB then is just going to be what? The negative of vector BA. So before you even start working, you should know that, oh, I have to change the direction of this one. So with this question here, I have to change the BA to AB first. So by negating this and that, then I can then sum them to find my AC. Okay. So then if I have my BA as this, then my AB is going to be negative of 2, 3, and therefore AB going to be minus 2, minus 3. Hence, if we are looking for our AC, then our AC, which we all know it to be what? AB, is supposed to start from A to B, B to C. So plus what? B to C. Then our AB, we add it to be 2, minus 2, 3. And then our BC, we add it to, we are giving BC as 1 and 5. So 1 and 5, so 1 and then 5. So at the end of the day, we have negative 1 and 2. Okay, as vector A to C. Okay. So please, you need to check the orientations or the directions of what the particular vector before you apply the triangular law of what? Vectors. You need to find the directions. So it is always advisable to draw whatever is given to you. So for instance, like the way I drew it for you, then you knew that okay, so this is the one causing the problem. Because if, for instance, I've been given to find what C to A, as this question here says what, find C to A, then in my drawing here would have been what, C to A. So it means C to A would have been C to B, B to A. So it means that this guy is rather the one who is not what, doing well, or he is the one that is giving us challenges. So BC is rather what we are going to turn. Okay. So every time the specific vectors are given to you, please try and draw them with the directions that are given here. Then when you get the directions right, then you realize that, oh, okay, the resultant is moving from C to A. So it's supposed to start C to B, B to A. Okay. If it is moving from A to C, then it's supposed to be A to B, B to C. So this is in the right direction, this is not. But when it's coming like this is in the right direction, and this is not. Okay. So just do that quickly, and whatever you have, then that is going to be your magnitude. So sometimes they can give you magnitude and one of these and ask you to do this. It's just a matter of change of sign. Send this to the other side so that it will become minus, and then you subtract as change of sign. No matter. Okay. So now let's look at the equality of vectors. The equality of vectors. Now if I give you that two vectors are equal, this one is just English language. Vector BC is equal to vector CD, right? Vector BC is equal to vector CD. So if that is what I'm saying, that vector BC is equal to vector CD, then we can say that okay, if vector BC is this, is equal to vector CD. And if vector BC is giving us x1, y1, and then vector CD is giving us x2, y2, then we can say that okay, then x1 is the same as x2, and then y1 is the same as what, y2. This one here, I've always been telling you that in vectors, the x's, they do their own thing, and then the y's also do their own thing. Okay? So if we are equating two vectors, then the x's should be the same, and then the y's should be the same. Okay? Let's take a numerical example like this. Supposing I give you something like this. Vector BC is what? 2x plus 5, then 7. This is vector BC. 2x plus 5 and 7. And then vector CD is giving us, should I say 3 and then 4. 3 and 4. And then the question is saying what? Find the value of x if vector BC is equal to vector CD. Find the value of x if vector BC is equal to vector CD. Then, this case here, if you apply the concept you are seeing here, then we say the x's should be the same and then the y's should be the same. So, practically what we are saying is 2x plus 5 and then 7 is equal to 3 and then what? 4. Okay. Let's do this 4y. Okay. So 3 and 4y. So you are asked to find the value of x and y. Okay, good. 3 and 4y. So what we need to do here is the x's we equate. So this is going to be 2x plus 5 should be equal to 3. Do you see that? So 2x plus 5 should be equal to 3. And then 7 should be equal to what? 4y. So when we pick this equation, we can find x And then when we pick this equation, we can find what? Y. Okay? When we pick this, we can find x. Pick this, we can find y. So hence, 2x plus 5 is equal to 3. Therefore, 2x will then be what? 3 minus 5. 2x is going to be negative 2, hence x is minus 1. So you finish finding your x. Then when you come to this side too, 4y is equal to 7. So y then is equal to 7 over 4. As simple as that. So we've been able to find the value of x and then y. Sometimes there can even be x here, so you have simultaneous equation and you put it in there like that. So that is how this is actually done. Okay, this is actually done. So if you have equality of vectors, they tell you one vector is the same as the other. It's just a matter of what? Equating the two. Then you equate the x's together, and then you equate what? The y's together. Then that is what we refer to as equality of vectors. Alright. So with this established, at the end of this whole video, I'm going to put what? A specific question on this one so that you can try your hands on them. And if any challenge, you contact us. Okay. So now let's proceed to finding perpendicular and then parallel what? Vectors. Perpendicular and then what? Parallel vectors. But before I go there, I want to bring your attention to one specific tool we use for the perpendicular, especially one specific tool. We call it the dot product. The dot product. Dot product. So if you are having dot product of vectors, what does it mean? Now suppose you have a vector, say vector A. Okay, vector A, and is giving us x1, y1, and then vector B, and that is giving us what? X2, y2. Then when I'm asked to find the dot product, that is the product of vector A and then what? B. The product of vector A and B, the dot product of A and B. Then this is equal to, you are going to multiply the x values plus the multiplication of the y values. That's it. So you multiply the x values plus the y values. So with the dot product, then this is going to be what? x1 times x2. Do you see? x1 times x2, then plus, there is no bracket. Okay. So x1 times x2 plus y1 times what? y2. So y1 times what? y2. So always the dot product is always going to give you a scalar as the answer, a constant, a number as the answer. For instance, let's say vector A that we did is 3, 1, and then vector B is 5 and then 2. So we have vector A 3, 1, and then vector B 5 and 2. And we are actually looking for the dot product of vector A and then what? B. Okay, we are looking for the dot product of vector A and B. Then we said it's going to be what? X times x. So this is going to be 3 times 5 plus the y times what? 1 times 2. Okay, so 3 times x, 3 times 5 plus 1 times 2. And 3 times 5 is going to be what? 15 plus 2. And that's going to be what? 17. So always a dot product is going to be a value. It's going to be specific value. So please keep this in mind as we graduate to our parallel and then the perpendicular. Okay. So let's start with parallel. Parallel vectors. So we're starting with parallel vectors. Now with the parallel vectors, what does it mean? Let's say we have a vector here, A, B. And then we have another vector C to D. Then we can say this and this are in parallel if their directions are the same. See? They are going towards the same direction. Like that. Okay? And the way it is lying down is the same as the way this is lying and all those things. Okay? This one can be in a different level in the plane, but at the end of the day, the way they are lying should be the way this one is also lying, just like parallel lines. Okay, just like parallel lines. So with the how to find if two vectors are in parallel, okay, then one should be a scalar of what? A scalar multiple of the other. Okay, so if I'm saying vector A and vector B are in parallel, then if I should multiply a scalar by vector B, if I should multiply vector B maybe by a scalar, right, then it should be equal to what? The other vector A. Are you okay? Then we say, okay, then one is a scalar multiple of the other. Then if that is the case, then the two of them can be in parallel. What I mean is this. Let's say I have vector A. I have vector A say 3, 4. Okay, vector A say 3, 4. And then vector B. So let me do it. Vector B say 6, 8. Then we can say A and B are in parallel. Why? Because when you use a scalar to multiply this, say 2. A scalar 2 to multiply this. Then this 2 times this will be 6. 2 times this is going to be 8. So if I should plot these two, one will be on top of each other, but the way they are lying will never change. Okay? The way they are lying is never going to change. Are you okay? So the direction they are going the same way and the same line, same thing. Okay. So fine. We just knew, maybe directly you will not be able to know. Let's say directly you will not be able to know if A and B are in parallel. Then how do you identify if vector A and vector B are in parallel? Let's say they ask you that question. Which of the following are in parallel with vector A? Maybe A, then they give you 6, 8. B, 7, 4. D, like that, objective. Normally these ones they are objectives. Okay. So how do we identify if two of the vectors are in parallel? 1. Just use normal scalar, normal ratio and proportion. If you divide, listen, if you divide the x value of this by the x value of this, and the answer you get is equal to the division of what? The y value of this and the y value of this, then we say the two of them are in parallel. That is what I mean is this. This is the x value, this is the x value. So 3 divided by 6. Okay? 3 divided by 6 should be equal to, when I divide this one by this, should be equal to what? 4 divided by what? 8. When this is true, then A and B are in parallel. So 3 over 6 is half, right? And yet is also half. Hence, that's why we said that, oh, okay, then A and B are in what? Parallel. So, generally, if you have a vector A being represented by x1, y1, and then vector B being represented by x2, y2, then we normally generally say that what? The ratio of x1 is to what? X2 should be the same as what? The ratio of y1 to what? Y2. If that is fulfilled, then you know ratio is the same as division. So if that is fulfilled, then we can say what? Vector A and the vector B are in parallel. As simple as that. So if I give you a question, this is vector A, and that is 4 and then 5. Then find the among these vectors, which one is what in parallel with this. So among this, which one is in parallel? Say I 7 and 8. Then I 20 and 25. Then we have I 66 and 100. Like that. This is how they will be giving you the questions. So this can be objective. So with that one, we just have to use the relation we are talking about. That when you have the ratio of x and y, you just equate them and see. So we pick this first one, and then we divide 4 by 7. So when we have 4 divided by 7, we'll see whether it's equal to 5 divided by 8. And this one definitely is not equal to, right? They are not the same. So this is not out. This is not in parallel with what we have. Then we have this and that. So 4 divided by 20 should be equal to what? 5 divided by what? 25. 4 here 1, 4 here 5, 5 here 1, 5 here 5. So 1 over 5 is equal to 1 over 5. That's good. So we have the first one known to be in parallel. So this one satisfies. Then we'll come 4 over 16, 4 over 66, then divided by what? 5 over 100. So definitely this is also not. So the only one that is in parallel is just going to be this. So always remember this. If this is true, then we say the two vectors are in parallel. Okay. Fine. Now let us go to perpendicular. So with the perpendicular, so let's look at perpendicular. Perpendicular vectors. So with the perpendicular, like I told you, we will be using the dot product as a tool to determine if two vectors are in perpendicular, okay? If two vectors are perpendicular. Good. So if that happens, what is going to, well, let's say for instance, I give you vector A, and this vector A is, say, x and y. Alright, and then vector B is, say, x2, y2. Okay, so we have vector A, vector B. So we have these two. For these two to be perpendicular, then we say the dot product of the two vectors should be equal to 0. When you find the dot product of the two vectors and it's equal to 0, then the two vectors are perpendicular. As simple as that. So the dot product is equal to what? 0. So, meaning that if I have x1 times x2 plus y1 times y2, it should be 0. when this is 0, then these two are in perpendicular. Okay, so for instance, let me give you vector A to be 3, 4, and then this one to be -4, 3. Okay, so these are the two vectors here. And then they're asking me to determine if the two vectors are perpendicular or not. Then we can say that we will use their dot product, right? So then their dot product here, this is the x and then x, so x1, x2. So this will be 3 times -4, right? 3 times -4, that's the first bracket. Then plus, then the y against the y. So 4 times 3. This thing should be equal to what? 0. And if it's truly equal to 0, then that's good, right? So then this and that is going to be what? -12 plus +12. So you can see clearly that this place is what? 0. Then we're going to say that, oh, okay, and this and then this are in what? Perpendicular. So whenever their dot product is equal to what? 0, then we say that the two vectors are in what? Perpendicular. The two vectors are perpendicular. Okay, so then let's say the same idea. I give you 3x and then 4, right? That's vector A. Vector A is this, and then vector B is 7 and then 20. So we have these two situations. Then I ask you that find the value of x. Find the value. Find the value of what? X. If what? Vector A is in what? Perpendicular. Is perpendicular to vector B. So they've already told you that this and this are perpendicular. So if that's the case, then find the value for what? X. Very simple question. Find the value for x. In that case, then you can just use the rule. Okay. So this x here times the x. So 3x times 7. Okay. Plus the y times the y. 4 times 20 should be equal to what? 0, according to the condition to be what? Perpendicular. So this one here is going to be 21x plus what? 80 should be equal to 0. So when we send 80 here, it's going to be 21x is equal to negative 80. Hence, the value for x is going to be what? Minus what? 80 over 21. So the value for x is just going to be minus 80 over 21. That's it. So you always have to just use this principle that the dot product between the two vectors is 0. If the dot product is 0, then what happens? They are in perpendicular. They are perpendicular. Okay. So they are perpendicular. One is what? The negative of this, and all that, and done. Okay. So we are done. Basically. Okay. So let me introduce you to the very last part of this lesson. Actually, two things. One, when I'm giving the magnitude and the direction, how then do I get it in the form x and then y? Because normally you realize that with all our conditions, parallel, perpendicular, and the rest, they are all in the form x and y. Imagine they've given you the vector in the form magnitude and direction. How then you get the x and then what? Your y. That is the concluding part of what? The vectors. Okay? How do you get the x and then the y? Very well. So now let's see how we are going to convert the magnitude and direction into rectangular format. That's the x and then the y. Alright, so for instance, I'm giving vector AB this way. So vector AB is 5, 30 degrees. This is what I mean. They've given me vector AB as what? 5 and then what? 30 degrees. So if it's 5 and 30 degrees, what do I do? Because this one is not, we can't say 5 is my x and then this is my y. No. They rather giving me the magnitude and then the direction. So if they're giving me magnitude and direction, I need to resolve it into x and y component. Now, there are two ways you can go by this. First, you can draw this. Okay? You can draw this and then know that this is always read from this place. Okay? The 30 degrees is read from the north. So, what is going to happen is that this is going to be 5 here, and then the angle here is 30 degrees. Hence, here is going to be what? 60 degrees. So someone can draw it and then say, okay, I'll resolve it. Cos will be for x, sine will be for y. Alright? Like that. Okay? But passing through this way is sometimes troublesome. Because you need to actually look at the part of what the Cartesian plane you are, or the quadrant in which you are, before you do some negations and positive and whatever. So I don't normally recommend that for students, okay? So in my lessons, I'm going to let you do straight without even drawing to know which one is forming an angle with the x and all that. No. So you are rather supposed to interchange something. Now if I want to resolve this into x and y component without having to think of anything, you have a lot in your mind, you don't want to think about anything, then you should know that I can resolve this vector AB into x and then y, into x and y component and this. The magnitude, let's say this r, theta, okay? Then it's supposed to be the magnitude sine theta. That will be the x component. Okay? And then the y component is going to be the magnitude cos theta. When you do it this way, you do not need to draw, you do not need to use cos and sine and bring the cos here and now be looking at whether the angle is acute, obtuse and all those. No. You don't need. Just use it this way, and then the negative and then these things will come direct. It will be taking account of what the quadrant direct. Okay. So for instance, this one here, we can then resolve the AB into magnitude into x and y component by, so x y component by this r, which is my magnitude sine this, so 5 sine 30, then the y component will be 5 what? Cos 30 degrees. So this one, if here is 300, it should be sine 300 cos 300. Whatever angle is given to you, just put the angle over here. Okay? Good. So this one here, 5 sine 30, that is sine 30 is half, so that's going to be 5 over 2. And then cos 5 cos 30. So 5 cos 30 is cos 30 is root 3 over 2. So if I multiply that by 5, I'll be having 5 root 3 over 2. So this is how the vector would have been. This will be the x component, then this will be the y component. Okay. Normally they will give you values that you have cheaper numbers, or maybe you can even convert this to the to the nearest whole number or something. Okay. So that you have a very simple strategy to do. So please, whenever the vector is not given to you in terms of x and y component, you can actually change it from the magnitude and direction component to x and y component using this formula. Likewise, you can do the reverse. You can also change the x and y component into magnitude and direction. Okay? Into magnitude and direction. Where the magnitude here, I can just do, if I am giving this in x and y, then the magnitude you know already as x squared plus what? Y squared. Okay? That's the magnitude of what? A and B. So AB vector, the magnitude is going to be x squared and then y squared. And then the direction in which AB will pass through is going to be what? The direction, theta. That theta you see here is going to be the tan inverse of what? The y value over the x value. So this. So they can use the x and y component to convert it to magnitude and direction. And you can also use the magnitude and direction to convert it back to what? X and y component. So either which way, you are going to arrive at a certain answer. Okay. So folks, thank you very much for joining this our class on vectors. There are more examples that you need to go into your books and then solve, following the little approach and then the little tutorials we have given you. Though it's in depth, but when you sit, you master more. Okay? So I will leave you with this assignment. Do it, and then you can actually contact the numbers for any confirmation in case of any challenges. Okay. We are ever ready to assist you. Okay. So see you in our next lesson when we will be tackling plane geometry. I hope you are going to enjoy that one. So see you.